Hello everyone, in this video we will solve a mathematical problem based on exponential distribution. In this problem, it's asked that a laptop produced company, XYZ say, uh, lasts on average for 5 years. The lifespan of each laptop follows an exponential distribution. So we are being asked to calculate the rate parameter first. So as we already know that in my previous video, rate parameter, solution for one, rate parameter, it is denoted by lambda, and it is actually the inverse of the average or the mean. Here average given us 5, so we will use 1 by 5. So that is it, our rate parameter. So we are successfully calculated our rate parameter here. Next, we are being asked to write the probability density function. As you already know that the probability density function, or the PDF, it is denoted by f of x, right? F of x, f of x is equal to lambda e to the power minus lambda x, where x greater than or equal to 0. So next question is that write the what is the probability that a laptop will last less than 3 years? So we are being asked to find a probability. Probability of what? Probability of less than 3 years. Suppose a lifespan where we can define it as a random variable which will be less than 3 years. So less than 3 years. So we can easily find out using CDF formula, because here lower limit is 0 and it will be 1 minus e to the power minus lambda x. Here will be 1 minus e to the power, what was our rate parameter? 1 by 5, yes, and x here will be 3, so 3 by 5. So this is the answer for this problem. It will be 0.4512. The next question is that what is the probability that a laptop will last more than 10 years? So it is the opposite of the previous one. Some kind of a probability. They will ask me greater than 10 years. So we can convert it in like the form of this, so that we can easily use CDF formula and calculate the solution. So here will be 1 minus probability of x less than or equal to 10. So now we will use CDF formula, which is 1 minus e to the power minus lambda. In this particular case, x is 10, so we will use 10. So 1 minus, what was our rate parameter? 1 minus e to the power minus, rate parameter is 1 by 5, so 10 by 5 here. This one and this one will be cancelled, so we will remain with e to the power 10 by 5. So what will be the answer for this? The answer will be 0.1353. Next, the last one, what is the probability that a laptop will last between 4 and 7 years? See, in this solving this problem, we cannot directly use the CDF formula, because by default CDF formula concerned as a starting limit or the minimum value of the observation is 0, like this one, like this one. But they are giving me the range of 4 and 7. So we cannot directly use the CDF formula in this particular case. Like they are being asked me to find probability of 4 up to 7. So we cannot directly use CDF formula, so we have to use indirectly. So we have to integrate suppose 04 to 7, and it will be using lambda e to the power minus lambda x, which is our PDF d of x, right? Lambda out of that, so sorry, 4 to 7, and we have e to the power minus what was our rate, lambda and x dx. Lambda, now we will easily calculate this one, minus lambda e to the power minus lambda x 4 to 7, right? So this one cancel, so we will remain with e to the power minus lambda x, and here, sorry, we will write here like this, e to the power, this one will be cancelled, right? We will remain with e to the power minus rate parameter is 1 by 5, so it will be, when we put the upper limit 7, it will be 7 by 5 minus e to the power 4 by 5, right? And there will be minus 4 by 5, and here we will have a minus as well. So after solving this equation, we will get the answer like this, 0.2027. So that is how we will solve this problem, this 5 individual problem of related to exponential distribution. So thank you for this part of the class.